All right, well, welcome back. And what we have right here is question number 2 on 5.3b. And we're talking about tree diagrams here and also different probability um, and how to solve it when you have replacement and independent events. So without further ado, let's just check out this problem. You can see the answers right here. We can go through this. Um, so whenever you're given a problem, so let's just identify some keywords. So in 2016 election, 30 states went to Republican candidate and 20 went to Democratic candidate. All right. Um, of the 30 states that went Republican, 29 were the continental United States. Of the 20 states that went Democratic, 19 are in the continental United States. So one state is selected at random. One state is selected at random. So we're going to construct a tree diagram here of this chance process. So right here, I'm going to say that R is referring to, all right, Republicans, all right, D is Democratic state, and C is continental U.S. And when you have this, so the Republicans, you can see, all right, if you would have Republican, it would be 30 out of 50 states, all right, there's 50 states total, all right, so 30 out of 50 states, that is what we have there. Going a little step farther is that we know out of the 30 states, we know that 29 out of 30 were in the continental U.S. and not, because there's a complement there, 1 out of 30 would not be that. Going over here for Democratic, we know that 20 out of 50 states were going to be voted Democratic. And then we have continental United States is going to be 19 out of those 20 states. And then we have, once again, our complement, all right, located there, which is 1 out of 20. Okay, so that's what tree diagram that I set up. Moving on, we're going to talk about, let's find, using that tree diagram, let's find the probability that a random selected state in the continental U.S. and went Republican. So continental U.S. and Republican, all right? So looking at this, we're looking at 29 out of 30, so we're going to multiply those two together, all right, because we're using our little rule, okay? And what we have then is going to be multiplied by 30 times 50. Okay, so we're going to multiply those two, all right, probabilities together, and what I got was 58%. All right, 58%. And so let's figure those out. Okay, and going a little step farther, all right, another question that you sometimes see is that if we select 4 states at random with replacement, okay, with replacement, all right, that means that each one has the same chance of doing it. So that means that the random is independent, all right, independent. Okay, so each chance process is independent. So the previous one does not affect the one coming up. So what is the probability that at least one of these states is in the continental U.S. and went Republican? Okay, so here is a little rule. So the probability of at least one is continental U.S. and Republican, we found out to be 58%. Now, how do we figure out if that at least one of those 4 states? Well, the probability of at least one of the 4 states would be the probability of 1 minus the probability of none being in the 4 states. Okay, so what we're going to do right here is if we take 1 minus probability of none, well, probability of none is 42 because for it to happen, it's a 58% chance. So for it not to happen, the complement right here would be a 42%, okay? 42% chance, or 0.42. And we're going to take that to the 4th power because what's happening is in our first roll, or first random selection will be 42%. Second roll will be 42%. All right. Third one will be 42%. Like that. All right. Then we have 42%. And then finally we have 42% again. All right. So each time what we see is that we have another 40%, which then makes that into, all right, 0.42 to the 4th power. All right, and that's what we got there, because each one is independent of each other. Okay, then finally, it says given, all right, so now we're talking about conditional, given that a randomly selected state is not in the continental U.S. So you can see right here, not in the continental U.S. What's the probability that it went Republican? Okay, so it went Republican. So we have this conditional statement. It's known as a conditional statement, or not conditional probability, not statement. That's different. Conditional probability. And what we're going to do is we're going to take the probability of being Republican and not in the continental U.S. All right, and that probability is going to be, all right, if you look up here, um, and we have that, and you can see that we're going to take so right there we're going to take 30 over 50 times 1 over 30, which is going to turn out to be 1 over 50. Okay, so that's how we got that. All right, multiplying those two probabilities together. So if you go over here, all right, we took 30 over 50 times 1 over 30. These will cancel out, and we're left with is 1 over 50. If you're wondering, where did that come from? All right, that's what we have there. Next thing is we were trying to figure out what is the probability of not being in the continental U.S. Well, there are two different probabilities of that one. And so what we have right here is we're going to take the probability of not being in the continental U.S. Republican goes here, so that would be 1 out of 50, and then Democratic would be 1 out of 50. So actually there is a 1/25th chance of that happening, and so that is where we get to 0.05. All right, basically that's going to be 1 out of 25. All right, 1 out of 25 that we get right there. Boop. Okay, and we divide those two, and we actually is a 50% chance that that would occur. Now you probably maybe could have thought about that naturally, but that's what we get for our answer. Okay, well, once again, question number 2, quickly just going through, talking about tree diagrams. All right, tree diagrams, talking about using tree diagrams to figure out end statements, figuring out using independent events, using tree diagrams, and then also figuring out a conditional probability problem. All right, well, I hope this helps you out, and good luck and God bless in the rest of your problems.